Hey, hello, and welcome. It's me, John Park, and this is Show and Tell. And I sure hope you can hear me because I don't see my mic thing bouncing up and down, but I'm sure someone in the chat will tell me if that's the case. We've got people chatting over in Discord. So oh, you can't hear me. Oh, no. Let's try to fix this. Let's see. That's weird. Testing, testing. All right. Well, I'll try that. Something happened on my other microphone, but hopefully that's working now because I see the little microphone meter bouncing up and down, or at least it was. Can you hear me now? It sounds like you can. Super. Scott says it sounds like my Friday. Did you have mic issues? Yes. This is Show and Tell. I'm John Park, and we're just finishing the preamble of things going weird with microphones, which is the alternate title for the show. So we've got a great lineup of people already waiting to come in. If you're interested in joining us and showing and telling things, I can pull these off so you don't see that reflection for a second. Head on over to Discord. It's adafruit.it/Discord. That's going to get you an invite link to go and jump into our show and tell on StreamYard. Now, what I'm going to do is bring on our first guest, and our first guest is joining us from Seed Studios. It's Anson Huh. Hey, Anson, how's it going?
Hey, good morning. How are we?
Wow. Oh, yeah, good morning. It is morning there, right?
Yeah.
Doing well. You look bright-eyed and bushy-tailed, wide awake.
Right. So, yeah, all good.
So what did you have that you wanted to talk about or show today?
Well, I want to talk, it's actually, we recently ported the CircuitPython onto one of our hardware, which is the Wio Terminal. And I want to talk about this, running the CircuitPython on this.
Excellent.
So basically what I did was, this was the original demo based on the PyPortal calculator. And it was, oh, the reflection is a bit dead. This is better. And recently, we just ported this demo onto our Wio Terminal, and it was originally on the PyPortal using the 2.4-inch TFT screen, but in touch screen form factor. And because Wio Terminal also have a 2.4-inch LCD screen, so we might as well ported that onto this. But we just converted that to a non-touch screen version. The reflection is pretty bad here, but yeah, you can see that is working properly as the same demo as the PyPortal calculator with the help of the Wio Terminal's 5-way switch. You can just move direction up and down, and yeah, so this is the one thing I really like about this CircuitPython running, because once the bottom layer is done, and you can pretty much port the demo onto other devices very quickly with no much issues. So yeah,
I like the little joystick. I haven't gotten my hands on one yet, so I didn't realize you had the little navigator at the bottom.
Yeah, that's like so this is the 5-way switch. So you can literally, we just convert the touchscreen contact to this 5-way switch to move different directions. And it actually looks really nice and looks really neat.
Very cool.
And I actually also working on another thing for myself using CircuitPython on Wio Terminal. If I just share the screen, I have another thing going. So if I just,
there we go.
This is the drive. If I just delete this demo, I have another one just working on recently. Back in. So this is what I really like about CircuitPython. One of the most favorite library I've been using is the USB HID libraries, because that one was pretty powerful. If I just, can you see my screen?
Yes.
Okay, so I just, so I have another demo. Oh, Let me just stop this. I have another demo which is running the USB HID library.
I like the icon.
So this is actually the default screen. So it just shows the macOS logo. Well, and it actually connects to like an encoder. So this is what I did. This is the simple like multimeter used for me. So let me just share the screen again. So I have the macOS default mode. So if I just rotate my encoder, it does all the volume for me. And if I press, there's the 3 buttons up on the Wio Terminal. So if I press the play button, let me just open the music thing for you. So if I play, I can play and pause the music very easily. And the next, showing this. This is very powerful for me because I use external keyboard and does not have the Mac layout. So this is like pretty useful for me when I try to work with like a non-Mac OS layout keyboard. I don't have these functional keys. And I also import like another mode. If I press the button, it's actually switching mode. And this is actually switching to the PS mode. So if I just rotate the encoder again, it does this for me. So I can literally just switch in between modes very easily. And do also
great. So that's sending like the zoom key in Photoshop
yes.
over and over.
I use quite a lot of Photoshop, and I always wanted like a multimedia controller.
Yeah.
Like the designer have. And literally, as soon as I have the running on the USB HID, I can literally just do this. I literally just switch in between with
that's great. Yeah.
With like a encoder, literally just switch in between.
I love that. It's really clever. I'm a big fan of using USB HID on small microcontrollers, and now that you've got so much integrated onto one device with the screen and the navigation, you can really get a lot done. And
you can just add a lot of shortcuts to it and just literally build your own multimedia controller.
It's terrific.
Yeah.
Very cool. Well, thank you for bringing those on. It's a really terrific looking device. Looks like it's a lot of fun to code it in CircuitPython to be able to get these types of functionalities, really useful stuff pretty easily. And I look forward to seeing what else you do with it. So please come on the show. I know it's early for you, but please come on again anytime and show us what you're doing.
Thanks. Sure.
All right.
Thanks.
Thank you so much. We'll see you next time.
See you.
Very cool stuff. I want to play with one of those. All right, next up, we've got our good friend Kevin from Digi-Key. Hey, Kevin.
Hey, JP. How you doing?
I'm doing well. First of all, your shirt is so awesome.
It is pretty cool. I love the new Digi-Key icon logo. It's made me pretty happy that we've done something pretty unique.
It's not the Kevin logo?
No,
I think it's also the Kevin.
I think we should call it the Kevin logo.
Yeah, the new logo is called the Kevin logo.
Yeah.
Thanks, Digi-Key.
Yeah, exactly. That was nice of them.
Very thoughtful.
So, how's everything going out in California?
I'd say things are pretty good, a little hot, but I'm not complaining. How about you? How's things there?
Oh, it's great here. The weather's always good here in the summer. Northern Minnesota is perfect. Now, with February, we could have a different conversation.
It's true.
But so you had a really fun unboxing on Friday night, or last Wednesday night, not Friday night.
Right on. Yeah, thank you. That was a lot of fun. That was a cool box with great stuff in it. And like I said during the live stream, we had a chance to build a heck of a lot of content around that since we had extra time before we shipped it. We thought we were going to ship it back, in March or April. That didn't happen.
Yeah, well, not a lot of things happened. March was kind of a bust.
So it looks like you have a new backdrop there. What's happening?
I do have a little bit of a new backdrop. I'm in an old bedroom, in my son's old bedroom. I'm remodeling my basement, so it's a mess and drywall, and you don't even want to know what it looks like down there. But
that sounds like a quarantine project.
I'm building a little makerspace down in my basement, so hopefully soon you'll be able to see a real space for myself. But I did want to just really quick show off the AdaBox. Digi-Key sponsored the AdaBox, and we were huge partners in it. We love being a part of the AdaBox. It's so much fun for everybody. I know there's over 4,000 people that subscribe right now, so it's pretty impressive, and we're very happy to be a part of it. So for those of you that don't know, I'm sure many of you do, this is a automatic plant watering system. These two nails you put in inside the dirt, and it will sense the moisture. If I try and hold on to both of them, now it's showing the soil's at 82%. As you can see, I don't have a plant with me. I have a black thumb. If I have a plant, I will kill it. So this actually might help me in the future if I decide to get a plant.
I've watered a lot of plastic plants in demoing and writing guides about this. So that was another problem.
I actually almost grabbed one. I know we have a plastic plant, and I was going to do that. I should have. That would have been pretty good. So basically what this is if it senses the moisture is less than 50%, it's going to turn the water pump on. You can see it pulsing here into my makeshift Digi-Key bottle plant. The opportunities with this using the Clue, I feel, are just unbelievable. You can set this thing up with Bluetooth using the NRF chip, and there's so many other options we can do. I'm kind of excited to play around more with it. I was looking, you said you had so many different learn guides around it, and I was looking through some of those the other day, and it's a lot of fun, and I think you can get this into even schools, or I'm going to have my kids play around with it. It's a good product. You guys did great on this one.
Well, thank you. Yeah, one of the things that I've explored a little bit, and I think there's a lot of space as far as things like schools and maker spaces and at-home learning, is the form factor fitting all of the add-ons for microbit, because there's tons of cool stuff you can plug a microbit into. So that's in turn stuff you can almost universally just plug the Clue into and find ways to talk to.
Yeah, I have used the Clue on a few of the add-on boards for microbit. It's pretty cool.
Oh, that's right. You showed some robots and things that you'd...
Yeah, I did. Yeah, I did show that on one of these show and tells. One thing I do like is your Discord channel. I mean, I was having some struggles today. Mm-hmm. I've used the Clue a lot. I've used CircuitPython a lot. And I'm like, why is this not working? I was getting so frustrated. I go on Discord, and it turns out I ended up including the wrong file. One of the library files, I included one that was made for the Cricut.
Oh.
And they were able to answer it within minutes. So, I mean, it saved me hours of frustration.
That's terrific. Yay, Discord. That's awesome.
That community is just great. So anybody working on CircuitPython, jump over there if you have issues. Well, I appreciate the time. I'm sure there's a lot of good projects coming on tonight that I want to show and tell. So,
hey, one question for you that comes from the chat over on Discord is, how do we get one of those cool Digi-Key shirts? Do you guys sell merch for that, or is that an employees only thing?
It's an employees only thing right now. The only merchandise we have is if you visit our facility, and just for the record, I'm going to say you have to visit in February. But if you visit our facility, we do have a store. You can purchase things.
Okay.
I'm been pushing to try and do more on our website because people do want Digi-Key shirts and hats. Yeah. So we'll see.
Great. Cool. All right. Well, thank you, Kevin. Thanks for bringing on your project, and we'll see you soon.
All right. Take care, guys.
All right. Bye-bye. Before I move on to the next shower/teller, I'll read from the chat. We had a question about Alvaro Figueroa asked, any plans on supporting the Wi-Fi on the Wio? And Anson answered, I think over in YouTube, yes, we are planning to support Wi-Fi on the Wio Terminal to CircuitPython. And right now we're working hard to fix bugs on Wi-Fi on the Arduino side. So that's exciting. Very cool to get Wi-Fi on top of everything else that's going on in there. So excellent. All right. Well, next up, we've got our own Scott Shawcroft. So let's bring on Scott.
Hello. Hello. Congrats again to Seed for Anson and Elaine for coordinating with me on doing show and tell. It's awesome to see them on here.
Thanks for helping set that up.
Yeah, and it's been great. If any other folks are in China and have trouble getting connected with us, I do have a WeChat account. That's how we coordinated. It's very popular in China and very accessible. So if somebody's in China and wants to know how to get a hold of us, that's an option. I'm just Tandut on WeChat. So that's a PSA. And sorry, my camera's. But yeah, that's cool. Great job, folks. I wanted to talk about the ESP32-S2 And I first want to give people a pro tip that if you have one of the Salas that has the antenna connector, you actually need to connect an antenna to it. Because I was doing Wi-Fi scanning and I was like looking at how many networks I was getting, and I was like maybe getting one, and I was like, this is very strange. And the thing is that the PCB still has the connector, or the PCB antenna, but it's not connected at all for those versions. So I actually attached an antenna and it worked much better. So I'll do a demo and show you the Wi-Fi's next to me. So if you pop my screen up, we'll see if it works. So this is CircuitPython running on the S2 connected. Hopefully it's still alive. There are some issues with it, but there you can see that it's just done a scan. And you notice that it came in kind of disjointly. So one thing I made sure and do is we actually scan individual channels and return the results as we do each channel, which should mean that it will be faster for you to get to find the thing that you want and then also connect. I was so sick of seeing this, like, I'm just going to wait for 2 seconds and then return you everything. By doing this like piecemeal sort of thing, we don't actually need as much memory either. So we'll be faster and use less memory. Which is great. So yeah, I've got scanning working. You can see I also got an IP address from my router after I connected to it. And you could guess which one of those is my router. And tomorrow I'm streaming because I'm taking Friday off. So if you've been watching my deep dives, just a heads up, it's 24 hours before. I'm going to go right after John Park's workshop. So keep an eye out for the deep dive at 2 o'clock tomorrow. And I'll be covering, starting to work on actually getting, either I'll do ping, which I want to be able to do, or I'll do some socket work. So we'll see. If you have an opinion, drop in the chat. And if you have questions, I'm available there as well. Great.
Excellent. So tune in tomorrow. That'll be 2 o'clock Pacific time. And
correct.
What is that, 6 Eastern?
5 Eastern.
5 Eastern, sorry. I'm always so bad with the time
zones.
Oh, boy. All right, great. Yep. Thanks, Scott. We'll see you tomorrow.
Thanks, John.
All right, next up, Anne has returned, snuck off to get a snack or something. I saw you sneaking around in the thumbnails. I can see you all, by the way. You're all in the thumbnails. Everyone wave. That's what the green room is like on StreamYard, in case you didn't know. There you are. Hey. Hi, Anne. I think you're on mute.
Yes. In process of moving, I finally found that one Radio Shack item that I really wanted to show you all. So I got this kit about 40 years ago. It is a photocell kit where it has all the parts and you build it and you put the little photocells here near your door, and then when somebody sneaks in, it goes beep. So this came as a kit, and they had all the parts to make it a nice enclosure and everything. These nice switches to set the modes here. And they give you the photocells, which actually one is just a 6-volt lamp, and the other is just a cadmium sulfide detector. So it's not overly sophisticated, but you know, it has really simple instructions in their little book on how to solder it up. You can see that this was pre you know, electronic layout. I mean, they didn't have computers that could do anything to lay out circuit boards. And just things on how to solder it and use it, and it was fun. And I built it and put it into a science fair, and won a little prize. So I really want to maybe try to find some vintage Radio Shack stuff just to play around with it. But I do have a few pieces back from the day. So
that's a really nice one. I've never seen that one before. Love it. Great enclosure and design. Actually, you know, something I was wondering is, it would be interesting to see the sort of internal branding chart that Radio Shack had, because they called some things realistic, some things Archer. I think there was a hi-fi brand that began with an O. and then they had Tandy stuff when they got into the computer side. I'm kind of curious how all that lines up, because this one says both Radio Shack and Archer on it, right?
Right. So it varied somewhat, and it was interesting that they reused Tandy with the computers, considering that was the leathercraft side of the business.
Yeah.
And yeah, they used Realistic, I think, for the hi-fi stuff, not Wi-Fi, hi-fi stuff.
Right. It was okay. Yeah. So it was.
Yeah. And a bunch of others, and that would be a good blog post too.
Yeah. And I'm imagining that never spent any time in the sun, because it hasn't.
No, the plastic's pretty good. I did have it mounted, so if somebody came in my room, it made a lot of racket. You know, I had a friend in there, and we were busy, and you know, I could do that.
That's excellent. Good, nice one. Well, those are always fun to see, and you've got a great collection of some really well-maintained stuff, especially the boxes. I'm gonna pull myself out for a second so we get another close-up of that box.
There you go. And let's see. Oh, yeah, this graphic too is cute. All the electric stuff, you know, they had to have lightning bolts or something for electrical stuff. It's just, you know, electronic and lightning bolts. I mean, how can you go wrong?
Yeah, that's fantastic. It almost reminds me, there was a mindset around doing the box art for Atari games that was so evocative, because the games themselves looked like nothing you'd want to show off in box art. And same with, like, there was so much excitement around the graphics and things with a kit that was fairly simple like this.
Mm-hmm.
Beautifully done. All right. Well, thank you so much. I look forward to your next treasure or project when you come on to show and tell.
No problem, John. Thanks.
Thank you. Bye-bye. All right. It's cool stuff. Man, I love the Radio Shack things. It's part nostalgia and part awesome. Let's see. Next up, we've got our own Aaron St. Blaine. Come on in. Hello.
Hi. So it is summertime, and I live in California, and the weather has just been amazing here lately. So I've been doing lots of resin projects. Like epoxy resin is a very fiddly medium, which if it's humid or if it's too hot or too cold or anything like that, it's a mess. But I've been having kind of a lot of success with it, and I've made something that I'm pretty amazed with. I made a resin. Ooh, let's see if I can get it on screen here. Ocean. Out of just some different kinds of acrylic with, what am I trying to say? Alcohol inks to make it translucent. And then I have put an RGB LED matrix behind it, running CircuitPython with some help from Jeff Epler, an Adafruit guy that was just great at doing code. And I've got it running this really cool animation where it looks like there's just magic bioluminescence under the water. And of course, then I had to, I got inspired by that movie Moana that came out, and made a manta ray, just like Moana's grandmother, who swims around under the waves in that movie. Is just really inspiring. So I'm really happy with how it turned out. It looks just really magical. I'm sorry about the reflections here, so if I can get it to show a little better. My power cord is too short. But I've been just having a ton of fun with this. Now, inside, I just have the front attached with magnets. And inside here, it's got a RGB matrix, as you can, let's see. You see, and then it's just got a power cord in here, and then I'm running a Feather M4 Express is powering the whole thing. And so it's a really simple build. It's just mostly like you build the board a little bit, and then everything just sort of plugs in. So I'm having an amazing fun time with this thing, and it just looks really cool with the ocean in front of it. That
is beautiful. I have questions. So first of all, the resin. What is the approach to doing as much sort of sculpting of the water and the foam and the color gradations that you have in the resin?
It is not hard at all. I actually did a whole process video, but you basically get a bunch of different colors of resin, mix them in little Dixie cups. So I had 5 different Dixie cups with different colors. And this is tabletop resin. There's different kinds of resin, which I'm going to write up in my tutorial. And this one it's self-leveling, so you pretty much just pour it over, and it'll level itself and pour over the edges and everything like that. But I mixed, I had like 4 different colors on the Dixie cups, and then mixed, you know, the orange or the blues and the sapphires and the greens and everything like that. And then I have for the waves, for the surf, I have mica powder mixed in there, which is a iridescent kind of shiny, shimmery mica powder. And then down here on the bottom, I'm using real sand and seashells that I just mixed in with the resin as well. So the whole thing, it's just so pretty all by itself. Like just, I mean, it's artwork by itself. And then with the alcohol inks, it makes the whole thing kind of translucent, which is why it looks so good with that LEDs behind it.
Yeah.
So, lot.
And then with your graphics, are you floating bitmaps, like raster bitmaps across the screen?
Yeah, and so we've got 3 or 4 different bitmaps in there. We've got the manta ray, and then there's a Moana. There we go, the Moana heart of Tucky symbol as well, which pulses. And so the code is pretty cool. It's got 3 different sort of modes. You can have the mode that's just the waves that goes. It just simply scrolls. And then the Moana heart of Tucky pulses, and then the manta ray actually it kind of goes back and forth as well as scrolling.
That's so cool.
And pulses too. So it's really neat, and it seems like it's pretty easy to update your own images, put your own images on, and adjust how fast the speed goes and how much torque it has. And all that.
Yeah, that's wonderful. You faked me out at first because the first thing I saw was the spiral, and I thought you had a layout of like NeoPixels. I didn't realize what you had underneath, and then all of a sudden you're doing things that there's no way she laid out that many different, but it's one matrix and a bunch of graphics. That's really a terrific way to do it.
I'm really happy with it. Like, it just looks so magical. And I had to, of course, watch Moana last night on Disney Plus and like cried my eyes out. But it's just such a beautiful image and such a beautiful story. And this, like, all my mermaid friends online are just going nuts over it.
Oh, that's terrific.
So, yeah.
Beautifully done. Okay, well, I look forward to checking out the process video you did and your guide when that's available.
Yeah, hopefully that should be up by next Tuesday or Wednesday. So.
Excellent. Good. People can go check that out. Thank you, Aaron. Amazing work. Beautiful stuff. Thank you. All right. Next up, we have Liz with City DIY. Hey, Liz.
Hello. How are you?
I'm well. How are you doing? What's happening?
Good.
What's new?
So I'm just gonna share my screen real quick. So I wrote some code for the MIDI drum project with Noe this week, and now I've gone full force into the PyPortal stream deck project. I have to be a little careful because some of these buttons are active now, so they'll launch programs. But
that's dangerous.
New menus. We've got Chrome and all the buttons there. Launch it, go home. You can also look at the source code, or I also put in a command for using cast too. And then I work in education, so of course I have a Zoom one. And it has all the Zoom things you could ever need. Firefox, basically the same as Chrome, and then Windows. So those are just some like standard Windows controls. Fusion. It's the Premiere and Photoshop ones that are active right now. And I know I've showed the emoji one before, but I just think it looks so cute. Show it again. So yeah. So about halfway done with that, so it should be coming fairly soon.
Great.
Yeah.
That's a really, really useful one. And I imagine you've set it up in a way that it's straightforward to add new pages and icons as you
I can
decide
actually, the code is a little unruly right now, but I can actually share just to show what's happening. So let me zoom in. So basically, like the graphics are all set up here as bitmaps, and then there's one set of buttons that are the 15 buttons that go across the screen. And then what I'm doing when I'm switching groups, just to save memory, is that I'm actually removing the buttons from that group and then adding it to the next group that's being shown. So it's kind of being hopped around, so that saves on memory. And then because it's one set of buttons, I can call on those names each time. So the button name 2, like I can call that later when I'm looking at the different pages of icons. So that makes it a lot easier rather than having a bunch of different names for everything. So the code will probably end up being kind of long, but it will be kind of easy to see.
Clear.
Edit. Yeah.
And one other quick question is, are you able to do everything with just sort of vanilla operating system and application shortcuts, or are you running like a hotkey manager on your computer to watch for some of the weirder
it's all built-in shortcuts right now.
Great.
And so yeah, everything's built in, and then I'll probably in the guide put in things for like your Mac equivalents, just kind of on Windows.
Right.
So yeah.
Yeah, very cool. Well, thank you for coming on and showing that. Great progress with that. Looking forward to it.
Thank you. Thank you. Have a good one.
Take care. All right, and next up we have Noah and Pedro. Come on into the show and tell. Hello.
Hey, what's up, folks?
Hey.
John, let me share my screen because I forgot. Here it is. Yeah, actually, shout out to you, John. So this is our MIDI solenoid project with CircuitPython, and we kind of took a little bit to kind of work out the mechanics for this mallet, and you brought to my attention data machines, which Kickstarter project a couple of years ago. So I basically kind of looked at that and redid it with 3D printing. So we put together a bunch of 3D printed parts. We kind of have it in two pieces. We have this mallet bit that has the solenoid mounted to it. It's got like this little cradle thing. And then this linkage bar here, which has like the mallet stick and this little dome here set to it. So it pivots at this point here, and then the plunger has it mounted there with another screw. So it creates this nice kind of mallet hitting motion. So let's make it set up. The real trick here is like setting up so you're striking the right spot. And yeah, so the controller box is right here. It's got that snap fit stuff to it. We have 4 broken out DC jacks, but the Darlington driver it has up to 8 inputs, so we could do theoretically 8 different solenoids, but we're doing 4 for now because we want to do it kind of simple. And it's just running the Feather M4 with CircuitPython, of course, and this kind of snap fits together like that. So you can plug in your things there, and then we have 12 volts power supply running in here. It's got 5 amps, I think. And so to set it up, I have it in Logic, and I just have the Feather assigned to a external MIDI track. So this one right here is mounted to a 2020 extrusion. That way we kind of hit like a more direct hit. You can't kind of see it in the shot, but the piston is like hitting right on that. This is a practice pad, by the way, for like folks that are starting out drumming. So yeah, so we have that kind of 2 setup. We got the mallet and the kick drum. We also created 2 more of these and have like a little baby cymbal. So we're kind of playing with cymbals. But it's pretty nice. You can play that, you can strike them all at the same time. There's very little latency, if any at all.
Yeah, I was going to ask about that. And you're a drummer, so you would have a good feel for how the latency feels. Does it feel pretty playable to you?
Yeah, people wanted to hear like the double bass. Like I don't have it set up to like I don't have the right key set up here, but I could write something in the piano roll in Logic and create some really fast stuff. But yeah,
we need to build you a arcade button finger drumming box too to add to the fun.
Yes, we got to revisit that at some point too. So yeah, you can expand upon it. You can hit different things. It doesn't have to be musical, I suppose. You can hit, I don't know, buttons and keyboards and
maybe some of the other Kickstarters we've seen is like the IoT thing, where it's literally just a little
button presser. Okay.
Yeah, button presser, and it's
right, maybe a light switch thingy.
So turning your AC into a
with Ethernet. Yeah, but you could use the parts for other stuff.
Yeah, that mechanism is really cool, and it seems like it's not far from those IoT things, or I think there were Kindle page turning button box things.
Yeah, exactly. And it is modular. I mean, we can take the mallet off here since I have it attached. They print it in one piece. So yeah, very neat parts. Yeah. Shout out to Liz for putting the code together. Before this one, she put together like a 30 solenoid xylophone. So that's a lot of fun with that one too.
Yeah, her practice run was 30 solenoids, so she's well ready to do this one.
Compact version of it.
Yeah. Okay.
Excellent, cool. And this one, is there a guide on the way imminently? Or
yeah, the guide was published. Yeah, the guide's published this morning. We got a little video that shows like the things. But yeah, check out the Learn Guide. There's some good stuff in there. Good code walkthrough as well.
Yeah, you can check out 3D Hangouts that we did earlier today, and there's a whole hour there just talking about all of the CAD stuff.
Yeah, a lot of folks asking questions.
Good. We'll play catch up with that. That sounds great. Very cool. Awesome project. Love it. Thank you guys so much for bringing that on and great work.
Thank you for hosting.
Thanks, John.
All right, bye, everybody.
Let's pull that. There we go. Thank you. By the way, one thing I'm excited about, and I'm going to show more of this on my workshop show tomorrow, but since we are broadcasting live right now, since Adafruit is on air, my on-air sign lit up. I've got it a little bit constrained by some wiring right now, but that is automatically running some checks on the YouTube data API. And it noticed when our stream went live and my little sign changed colors there from off air to on air. So I'm excited that I had a real world test of it when I wasn't expecting it. So come on by tomorrow and I'll talk more about that on my workshop show. All right, next up we've got Tim. I'm gonna bring Tim into the stream. Hey, Tim.
Hey everybody, so I've been on a little bit of a vintage electronics kick. Oh, and first off, I'm liking the evolution of facial hair over.
Thank you.
Using over the last couple.
Stay entertained over here.
So I've been on a vintage electronics kick. So a little while back, I talked a bit about the tube tester, and I'm still figuring out how to maybe do that on a show and tell with a couple cameras. But you know, since I need more projects, so I actually picked up another vintage radio, and I'm just trying to switch my cameras here. So here it is. So this is an AM radio from about 1940, and had to do some work on it. You know, the capacitors and resistors mostly were out of tolerance. I replaced them. And this little guy is not a vacuum tube anymore. It's actually the base of the rectifier tube. The rectifier was shorted, but it could be replaced with a couple of diodes and a resistor to give the proper voltage drop for the old rectifier tube. And I just built that into the base there. And then the other thing is, from our friends at Digi-Key, I got some power resistors, and I used that to drop the line voltage from today's 120 to 125 volts in the US down to about 115, which was kind of the standard in the US a long time ago in the 30s and 40s. But let me take you around to the front so you can see some of the tube filaments glowing there. And then around to the front, you can kind of see the old-timey radio here with a nice kind of pilot light illuminating the dial and so forth. A nice Art Deco styling, and the thing actually works. So that was nice. You know, need a little bit of refurbishment, but it was nice to kind of save it from an uncertain future, maybe as a parts chassis or something like that. So. Yeah, so just a little update there on some quarantine projects.
Yeah, nice work. And I love the preserving the form factor of the vacuum tube and building your own rectifier in the base. Did you add the plastic cylinder to keep the shape roughly the same?
That also, it's actually just cut from a medicine bottle. The main thing is like a little chimney to allow a bit of heat from the resistor to escape, and also to prevent me from, or anyone from, actually touching the high voltage components. This radio does have a transformer, so the actual chassis is isolated from the AC lines. It's a little bit safer to work on, but you still can have relatively high voltage DC from the rectifier. So just having that there for some protection keeps you from getting zapped. I know some people put like little LEDs in there to make it glow like the filament and stuff, but that's just get a darn thing working. Yeah.
Oh, that's great. I love the medicine bottle hack. I didn't identify it as that, and now it's obvious that you say it, but it's perfect. That amber color is so fitting.
And it's exactly the same diameter as the tube base, believe it or not. Probably 1 inch, 1.25 inches, something like that.
That's the best. If you're a fan of that, there was a blog that was around a long time ago. I think it's still there. I don't know if they updated, but it was called Things Fitting Inside of Things. And it's literally just amazingly wonderful, accidental, like, you know, this hockey puck is identical to the size of this coffee cup holder or whatever. And it's very satisfying. So.
Yeah, I was trying to keep this cheap and cheerful. So trying to repurpose stuff I had around to kind of get it working. So,
and I hadn't realized that about the difference in AC voltage being 10 or 15 volts lower in the 20s and 30s.
Yeah, it was like 110, then 115, then 117, and now it's about 120 to 125, at least in North America. So sometimes you can stress older equipment if you just plug it in and fire it up.
Yeah. Oh, that's interesting. I had no idea. Well, thank you so much. We learned a lot and saw some very cool things with your radio there. I love that design. It's a gorgeous piece. So thanks for preserving it.
Thanks for having me.
Yep, we'll see you soon. Take care.
All right, see you next time.
All right, next up, we've got Jeff. Hey,
hello. Jeff. First of all, I've just got to say, nothing I'm going to show is half as cool as what Erin had to share with us, and I'm so privileged to get to work with her. So
thank you for your work, your collaboration with her on that. It's a gorgeous project.
Anyway, so I've come on Show and Tell a couple of times talking about things related to timekeeping, and today I'm ready to show the clock I've been working on, which is this little guy, and of course the lighting makes it hard to see the LEDs, but anyway, we're local time 1840 and the date 0805. So basically I want a clock that I don't have to mess with, I don't have to set, unless the law changes or I move to a different state. So we're running off of a battery, but normally you'd be plugged in on USB. But because it has the real-time clock, if you lose the battery power of the battery that runs the displays, it will, well, normally, it will reset and you get your time back because it's got the real-time clock module, which you can't really see down there, which is carefully calibrated to within about a second per month. It adjusts for daylight saving time, and I guess that's about all it has to adjust for. And so it's got this construction with the front layer of the displays, the middle layer of a feather quad, and then the back layer of the real-time clock. And I think it's a Feather M4 Express. And I will drop the links in the chat, but I've blogged about a lot of the steps to doing this, such as there's a little interesting wire here. Why is that wire there? My blog explains it, and I will share that. But that's what I've been up to. That's why I've been blogging about timekeeping with Python and CircuitPython.
Great clock. I love that you include a teaser there for find out more about the mysterious wire. Got to know. So everyone run out and find out. I'm dying to know. And that's really, that's terrific. It's a lovely build. I really like the use of the Charlieplexed LEDs, little diagonal LEDs look really nice.
Yeah, the boards are really fun. And of course, with all LED things, it looks better in person. Oh, it looks a lot better actually back here. So that gives you a real sense of how it looks, except greener. I might do it again and put a different color display on the bottom row just to emphasize the difference. But yeah.
Beautiful. And as with all things lately, I'm tempted to put either theatrical gel or car tint or some of our LED plastic in front of them. And some stuff works well with some things it doesn't, but
I've done a little experimenting with 3D printed natural plastic, and I haven't been satisfied with it yet, but I'll probably, and I've got this enclosure, I guess I should say I've got an enclosure for it to go in. I just haven't quite deciphered how the enclosure is going to work together with putting a piece of acrylic in front. So there is a little iteration left on the design overall. But yeah, getting those diffused so they're not so harsh. Oh, it adjusts the brightness. So this is daytime brightness. And then at bedtime, it goes down to the lowest brightness level. So that means you don't blind yourself. So that's another fun little thing that is easy to put in with CircuitPython.
Right, and that's a good way to do it. No need to complicate it with sensors and photo cells. You're doing it based on at this time I want it darker. So.
Right. If I should be in bed at this hour, then it should be dark.
Then stop.
Then it's a cue for what you should do, not reacting to the fact that you finally turned the light off in the living room.
Great. Well, thank you, Jeff. Beautiful project. Love clock projects. I'm going to go find out about that wire. It's killing me.
All right. Wait till after the show, John. You got to wait.
I will. I'll finish. All right.
Good night.
Bye. All right. And speaking of clock-like aficionados, we have Paint Your Dragon. Hey, Phil.
Hey there.
Hey, sorry, I didn't give you much warning. Hopefully you could tell who I was about to bring on.
I didn't know that. I didn't know I was.
Your name was mentioned today in context of clocks. Lamore said something. That Phil's a matrix
earlier today.
master,
Okay,
so.
yeah. but like
so-
regular watchers won't even know what we're talking about. I barely knew what we're talking about. By the way, Optimus was the Radio Shack speaker brand.
Thank you. Yeah, that's right. It was the speakers. Okay.
There's
Optimus.
a Wikipedia page on the Tandy brand, and they mentioned there's like a dozen or so related brands that they had. Like equipment, and there's ones I don't even remember. Flavor Radio, where these portable radio. I didn't. That's
Flavor.
Flavor Radio. They were little colorful AM radios.
Huh.
Let's see. Anyway, I'm changing cameras here.
Okay.
Come on, camera. There we go. Okay. It's going to focus. Yes. All right. So I did an update to our OV7670 camera library, and there's an update to the guide. I will post the link to the guide. And basically, I added a few effects we can get out of the camera, like image rotations and stuff, plus some simple image processing effects, just for fun kind of stuff. They're not like scientific applications, but there's like some edge detection. I think, yeah, now it'll do image flips, then it'll do test patterns. So that's all in the library now. It's all updated in the guide. And I also gave some directions there about, like I mentioned a while back, about changing the focus on these lenses and stuff. So that's all live. It's there to go in the guide. Currently, all works on Grand Central, but it's one of those it's not out yet things. But I am working on a featherwing adapter for the camera. I don't know if it's going to work, but that's a little something fun I'm working on. And it's kind of chunky right now. It'll hopefully get a little slimmer. Did you ever see a movie in the 80s called Brainstorm?
No.
It was about a machine that could record and play back experiences. And one of the things I loved in the movie is every iteration of the hardware got more and more sleek as the movie progressed. And so, we got Grand Central here, and now we're down to feather, but it's a chunky feather. And I'm hoping a couple iterations, it'll get down to, just a little featherwing size thing. We'll see what happens.
That's terrific. And remind me, these are, what is the interface, the camera interface that you're using?
It is, what is it called? Peripheral capture controller, which outputs 8 bits in parallel.
Okay.
Here's the link to the guide. Yeah, so it's not like a common thing like SPI. It's something very specific that only, like the SAMD21 doesn't have this peripheral, but the 51 does have it. That's how we're able to get this live feed off the camera.
Right, got it. And these cameras, what do these modules come from? Are these like a typical CCTV module, or are they in?
Some versions that like cheap webcams. I'm sure when these came out, they were probably cutting edge webcam type stuff, but now they're kind of like the old LCD displays. Now they're available really cheap to hobbyists. Yeah. So I think I found like a 2-pack on Amazon for just a few bucks.
Wow. Oh, that's exciting. Good. Well, thank you for the link to the guide. I'll go check that out too after I find out about Jeff's mysterious wire. Now I've got 2 things, as well as the Radio Shack link. And thank you, because Optimus, that was really going to bother me. But
sure. I got 1 sec for one other thing.
Definitely. We have time.
August now, and Halloween starts August 1st. Ooh. That's the rule.
I'm already late. Jeez.
So some of the stores are already getting their Halloween decor coming along, and Home Depot, I've been waiting for this to happen. They have this werewolf. I just got one. It's big. I couldn't bring it in the room. It's just too big. It's 7 feet tall, but I pulled his head off.
And his shirt. You're wearing his shirt.
Yeah, and I'm wearing his shirt. Yes, but they're finally starting to put the blinky eyes in the Halloween decor. And funny thing, looking at their website, they have a big skeleton, like a 12-foot tall skeleton, and they have the werewolf, but I like werewolves, so I got the werewolf. I recognize the skeleton's eyes because for our eye project, I took photos of my roommate's eyes, and that was the graphics resources we used in our code. And it's like, I recognize that skeleton's eyes.
That's amazing.
Yeah. And so, that's fine because it's all open source. That's what we do. Like, hey, But what I'm going to do, I think the werewolf is using something different. But I do plan, I'm going to peel this back. This will probably have to wait till the weekend or something. But I do want to compare and contrast, like the hardware, what goes into something. You know, we make these things for hobbyist onesie twosie, but when you're making these things by the thousands, I'm curious to see, you know, how this evolved to turn into a mass produced item.
Yeah, that's a really fascinating one, honestly, because the cost, they have to get it down to a fraction of what we are making for, just based on the scale of what they're doing. I imagine there's just incredible optimization and efficiency that they have to.
Those penny screen.
Yeah.
But I will blog this, or maybe even do a guide, just showing, because I think other folks might be, you know, interested. It's like that brainstorm thing. It's like it's going to get sleeker and sleeker with each revision.
Yep.
And
yeah,
it's in there.
Right, and eventually you'll be interfacing those things that cost $1 into a Grand Central, and then a Feather, and then an ITZY. And all of our stuff will have been turned into some module that you're then kind of trying to talk to again.
Yep. Alrighty, that's me.
Excellent stuff. Thank you for coming by and showing and telling. Really enjoyable stuff you're working on and showing off. We'll see you next time. And let's see, next up we've got Ian. We're going to bring on. Hi, Ian.
Hey, how's it going?
Oh, it's going well. How are you today?
Good. So I just wanted to show off, I guess, this is an automated tarot card reader.
Ooh.
So when you push the button here, it's a split flap display. And so it goes through all 78 tarot cards and it picks one at random. And then it uses the Adafruit thermal printer to print out the reading for the card. So it gives you your own personalized tarot card reading.
That is beautiful. Really awesomely done. Tell us more.
So basically, I have the stepper motor here and it runs in like a micro stepping mode. So what I did was I just, normally a tarot card deck has 78 cards. So what I did was I added an extra 2 because you need a home card. And then I wanted to make it an even number. So basically it comes down to if you divide the number of steps with the number of cards in the flaps. This is the spool here you can see from another version. And so basically every 20 steps, the machine goes to a new card. And so that way you have a number assigned to each card. And that's why the printer knows what your reading is. And so each card also has 3 unique readings that it can give, because in tarot card reading, there's like if it's upright, it's a positive reading. If it's upside down, it's a negative reading. And then I gave it kind of an ambiguous reading. So the machine itself can give 238, I think, 238 unique readings.
That's terrific. And so you came up with the split flap. So you cut all your cards in half. Is that?
Yeah, basically. So each one sort of like you can see each card has the top of the next card. So you put the bottom of one card and the top of another card on the next one. And that's how you get all of your cards in the display. And then it finds home because there's like there's a Hall effect sensor and there's a magnet in the spool. So that's how you know you can home your, what do you call it? Your stepper motor.
Oh, that's great. I also love the guides that you cut the cards, the channels, so that they would fit around that circle and kind of keep things
in line there.
Yeah, that's really beautifully done.
Thank you. And then you can see, I think I have another. So this is kind of the guts of the whole thing. So there's like an SD card because so the thermal printer prints with bitmaps. And so you had to convert everything into a bitmaps, and then it was just way too big to be stored in flash memory. So got it on an SD card module, and then got your stepper driver, and that's basically the gist. I mean, it's 3D printed housing and then a laser cut acrylic for this guy.
That is terrific. And besides that, this is just cool to make and have. Was there an application in mind that you made it for?
Not really. I just kind of so I have to give a shout out to there's this guy Scott Bezic who did a alphanumeric split flap display. And that was kind of the start of it. Was I built that one, and then it just kind of dawned on me like what else uses cards, and then I decided the tarot card reader would be a good project to do. And it ended up taking quite a while, but I'm happy with how it's coming out.
Yeah. Oh, really cool.
Yeah.
Very, very beautifully done. And have you got any write-ups or extra photos and things that people can go check out online?
Yeah, so I have a full write-up with all of the files, so all of the like STLs and the laser cut files, the print files for all the cards, everything. And then also, yeah, on Instagram, on the same name that I have down there, the iMosey, I put like all of the process photos. And so you can always like, if anybody ever wants to build one and then ask, you know, I would love to help.
Yeah. Oh, that's a really, that looks like a fun one to build. I'm tempted to do one. That's really cool. Beautifully done.
Thank you. Thank you.
Yeah. Well, thanks for coming on with that. And please come on again sometime with any projects you're working on. I'd love to see
definitely.
it.
Thank you.
Thank you, man. Excellent stuff. All right. Next up, we have Patrick, who's been waiting patiently, and bring you on in now. Hey, Patrick.
Oh, hi. I didn't realize that I'd actually make it on today. Very end. I'm just amazed at all the projects that people do with feathers. It's like
amazing stuff,
mind-boggling. So my project sort of hopes to add to what other cool stuff that people are doing, because I'm here to talk about my power over Ethernet featherwing. So you know this guy, you sell it. This is the Adafruit Ethernet featherwing.
Mm-hmm.
So I extended it to have power over Ethernet added onto it. So this way you get the Ethernet connection, but you also get power, 4 watts, if you have a power over Ethernet switch that you hook it up to. And you can pretty much use it with any feather that you have. I've tested it with the standard M0 with Arduino, and then with the CircuitPython using the M, which one is it here? The Feather M4 Express, and it even works with the Giant board, which is Grogard's Feather Linux board, we'll call it. So I have this one running here at the moment. So this, okay, which way does it go? So as you can see, it's connected. No other cables, just the Ethernet connected, and this makes a nice little Linux at the end of a cable setup.
That's really cool. So do you get, are you stepping 12 volts down to 5 to run the board? Is 12 typically what's going over the power over Ethernet, or is it up to you?
No, it's actually 48 volt.
Okay.
So it has the circuitry on board to do the IEEE 802.3AT spec power over Ethernet, and then it has the isolated flyback transformer setup. So this little part here is basically what's on your original Ethernet featherwing, and then I added the power stuff here. Plus there's well, this is the Giant board here. Let's see. There's the little chip on the bottom here that provides a MAC address, unique MAC address.
Very cool. We have at least one person in the YouTube chat, David Wills, who says, "I want that PoE featherwing."
Well, if you want it, I'm running over on Crowd Supply. I'm running my campaign right now, so anybody who can get one.
Great. So if you want to find that, what should they look up? Power over Ethernet on Crowd Supply?
Yeah, it's called PoE featherwing.
Oh, terrific! Excellent.
Power
we'll read that up. And if someone wants to put a link over in the Discord, that'll help people find it too.
Yep, I'll put it in there.
Excellent. Great. Thank you so much for showing that. Looks very cool, and good luck with the campaign. Please keep us updated. All right.
All right,
Patrick. And we have time for one last show and tell. It's Dylan. Hey, Dylan.
Hello. How are you doing?
I'm well. How you doing today?
Good.
What have you got to show us?
So I'm going to try to switch my camera around on here. Oh, whoops, I just turned it off. Classic. Let's see. Okay. All right, so this is the project I've been working on the last couple months, actually. It's I call it the macro popsicle. It's a little 6+1 key keyboard. So right now I just have it programmed for some emojis. So I'll just send a couple to the live stream chat. And then the extra key is actually on the stick right here. Oh, and I might have lost audio.
We can hear you still. I don't know if you can.
Okay.
Yep.
You cut out for just a minute for me, I think.
That is awesome. I love your keyboard. So tell us about the build. Is that what's the casing made from, and how'd you build the board?
So the casing is all PLA 3D printed, but I had to do quite a bit of painting on it.
Okay.
You can actually see in a few places I didn't quite paint enough on it, so it's starting to rub away a little bit now. So I have to go back and do another coat at some point. So the body is all PLA with some Montana spray paint, and then the internals are this PCB from JL PCB plus a Arduino Nano. And I wanted to show these because that way I can kind of show off the internals a little bit without taking this apart, because it's a real mess in there right now.
That's fantastic. So I missed, did you have the popsicle stick as a 7th key?
Yeah. I'll send a, it's right now it sends an island to Discord, so I'll send that again.
That's great.
Thank you.
Oh, Dylan, I love this so much. I'm a fan of creative small macro pads, macro keyboards. Have you published any info about this anywhere that we can learn more and find files and any stuff like that?
So I'm going to publish files soon. After I did the first build, I would say there's a lot of learning that came with it. So before anyone else goes and tries to make one, I want to make a few design revisions so that everyone else's build experience is better. And I'm actually running a interest check right now to see if anyone would like to buy a completed kit of this.
Fun.
And I can drop that in the chat as well once we're done here.
Excellent. Do you post something like that in like our mechanical keyboards on Reddit?
Yes.
Is that where that
happens? I did. Yeah.
Awesome. That one is just beautiful. I love the style of it. Where did this come from? Were you eating a popsicle stick and it came to you? Like, any idea of where the origin of the idea came from?
I was trying to think where it came from just now. I'm not totally sure. There was another one called the 2% milk.
Oh, I've seen that. It's like a carton.
Yeah.
Right?
Yes. So I'm going to give whoever had that idea some credit for this, because I have a feeling they inspired me, but I can't.
Yeah, it lives in that space design-wise.
Yeah.
I love it, and now I'm very unhappy with how boring and square my little macro keyboard. I'll go check out your interest check.
All right, thank you.
Thank you, Dylan. Thanks for bringing that on. Very cool. Look forward to seeing more, and we'll watch for your emojis to show up over in Discord.
All right.
Thanks. Take care.
Thanks, you too.
All right, amazing projects. We are out of time. We've gone a little bit over, but thank you all for stopping by to show your great stuff, and for joining us to go watch over in the different video streaming places where we are. For Adafruit, I'm John Park. This has been Show and Tell, and we will see you next time. Bye-bye.